Welcome to this platform. So we continue with 2024 internal science paper 1, which is physics. So previously we covered section A, so we answered questions from A1 up to A20. Okay, so in this one is a part 2, we answer section B. So for section B complies of 45 marks, and this one you answer all the question in this section and you write your answers in the spaces provided in the paper. So here is the first question. So the first question reads, which is B1, figure B1.1 is showing the time recorded on a stopwatch for 40 complete oscillation by Elena during an experiment on a simple pendulum. So as you can see, this is the stopwatch and the time it's showing there. A question is that state the time taken in seconds for the 40 oscillations. State the time taken in seconds for the 40 oscillations. So in this case, the time taken, as you can see from the stopwatch, there's 1 minute 40 seconds 00 milliseconds. So to find the time in seconds, we just simply add we just add the time in seconds. We already have here 40 seconds. A minute, we need to convert it into seconds. So we are going to have 1 minute in 2 seconds is 60 seconds plus 40 seconds. So we are going to have 100 seconds as our answer. So our answer is 100 seconds. Okay, so this is how you present your work. Then the second question, which is B, calculate the periodic or calculate the period of the pendulum. Calculate the period of the pendulum. Now, you know that period is simply the time taken for the bulb to complete one oscillation, okay? Or it's a time taken for one complete oscillation. That is the period. Now, how do you calculate the period? And period, you know, is measured in seconds. So period, capital letter T, is time taken to complete one oscillation. So number of oscillation, N. So the data that we have here is that T we have is 100 seconds. Number of complete oscillation we are given is 40. So we can calculate the period simply by replacing 100 seconds divide 40. And this is going to give us 2.5 seconds. Period is measured in seconds. So 2.5 seconds is the period. So 2.5 seconds. Okay. So 2 marks for that. So for you to earn a 2 marks, the formula should be there. You replace with the units and of course the final answer with the units. Let us look at the second question of B. Calculate the frequency of the pendulum. So frequency F, since we've already found the period, you use this formula 1 over period, where you replace 1 over the period that we found is 0.5 seconds. 1 divide 0.5 second is going to give us 0.4. Frequency is measured in hertz, and frequency is the number of complete oscillation per unit time. That is frequency. So the answer is 0.4 hertz. But there's another way you can find this one using the formula frequency. This time around, you know that the formula for period is T over N. So this time around, you just use the reciprocal of this one, which is N over T. Number of complete oscillation is 40. The time is 100 seconds. If you divide this one, should be able to give you 0.4 hertz as well. So whichever you are comfortable with. Okay? But it's very easy to use this one if you've already found the period. So it's straightforward. I guess up to this point, everything is okay. So we can proceed to look at the second question. And the question that is B2, first question is state Newton's second law of motion. So what does Newton's second law of motion state? So this is the question that I give you. So answer, what does Newton's second law of motion, what does Newton's second law of motion state? So you should be able to type this answer in the comment section. And of course, we'll be able to verify. So please, this part, make an effort to answer this one. B question, a block of mass 500 grams is pulled from rest on a horizontal frictionless bench by a horizontal force F and attains a velocity of 8 meters per second in 2 seconds. The first question is calculate the uniform acceleration of the block. Now, for you to calculate uniform acceleration, you can use, if you have force, you can use force is equals to mass times mass times acceleration, where mass is supposed to be in what? Kg. But we don't have any force here, so therefore we cannot use this one. But there's another formula that you can use for acceleration. Acceleration is equals to final velocity minus initial, divide time. How do you know the one that you use? You need to collect the data. So what are you given in the question? You are given mass of 500 gram. We just pick the information. Then you are saying starting from rest, put from rest. So which means the initial velocity is 0 meters per second. Then we have attains the velocity, which means that is the final velocity, 8 meters per second. Then we have the time, which is 2 seconds. And therefore we have final, initial velocity and time. We can use this one. So final is 8 minus 0 divide t. And this is going to give you 2 meters. Is it 2? Let me just replace even down here, 2. This is going to give us 4 meters per second square. So acceleration here is 4 meters per second square. Okay, that is our acceleration. So please make sure that you present your work nicely. Okay, this, make sure that you put it somewhere so that it does not join with the answer. Okay, so you need to put a separation between the answer and all these, or the solving and the data. All right, the second question is find the force of F, value of force F. So force F, or to find force, we use this formula. Force is equals to mass times acceleration. Okay, mass is supposed to be in kg, and it's the mass given here. A block of mass 500 gram. So we need it in kg, so we convert. That is 500 gram. You know that 1 kg or 1 kilogram is equals to 1000 gram. So this and that cancels. So it's just the same as the 500 kg divide 1000, and this gives us 0.5 kg. So the answer here is 0.5 kg. That is the mass. Okay, 0.5 kg. Then now we apply in the formula. So we are going to replace mass 0.5 kg multiplied by acceleration is this one that we found. That is the acceleration of this block, 4 meters per second square. 0.5 multiplied by 4 is just the same as 4 divided 2, which is 2 Newton. So the answer here is 2 Newton. Question 3. Figure B3.1 is showing a simple pendulum bob of mass 200 gram. So the data here we take note. The mass is equals to 200 gram. In kg is 0.2 kg. Okay, I'm sure by now you know how to convert. So we need it in kg, unless otherwise. Okay, so bob of mass 200 kg swing from position A to position E, as we can see from here up to there. Okay, but in between there's B, C, and D. Okay, let us look at the questions. And this is the ground. From the ground up to where B is 120 millimeter. All right. So at position B, the pendulum bob is 120 millimeter away from the ground and has speed of 0.90 meter per second. Calculate 1 kinetic energy. Now, how do you calculate kinetic energy? And of course, kinetic energy is the energy possessed by the body in motion. Okay? So, kinetic energy, the formula is half mv square, where m is the mass in kg and v is the velocity in meter per second. That is something you should know. So now to calculate the kinetic energy here, we are going to need the mass in kg. And of course, the mass that we have here is 200 gram. I said in kg is 0.2 kg. I guess you know how to convert. So 1 over 2, 0.2, then multiply, velocity is 0.90, but square. Okay, so you should be able to multiply this And what are you going to get if you multiply? So kindly confirm what you are able to get. Otherwise, for me, I'm getting 0.081 joule. Energy is measured in joule. So therefore here is 0.081 joule. That is the energy. All right. Then for the second one, gravitational, or calculate gravitational potential energy of the bulb. So gravitational potential energy is equals to mass times gravity times height. And this is the potential energy due to configuration or height. All right. So mass is supposed to be in kg here as we calculate. So M for mass in kg. Then gravitational field is 10 Newton per kg. That is on Earth. Height is given. That is for B. We are dealing with B. So position B, from here the ground up to there, the height is 120 millimeter. But there's a problem. We need it in meter. So we convert 120 millimeter. 120 millimeter. You know that 1 meter, we convert it to meters. 1 meter is equals to 1000 millimeter. So here it's just the same as 120 meter divide 1000, which gives us 0.12, okay, meter. Okay, so we've converted the what? The height. Then what else do we need? The mass, we already have it in kg, is 0.2 right here. Okay, the mass is 200 gram. In kg is what? 0.2. So we can replace mass 0.2 multiply by, okay, 0.2 kg multiply by the gravity is 10 Newton per kg multiply by the height, which is 0.12 meter. And this is giving us, if you multiply this, it's giving me 0.24 joule. So kindly confirm 0.24 joule. Okay. All right. That is the gravitational potential energy. Then C question, as you can see here, calculate the internal energy of the bulb. Now, what is the internal energy of the bulb? So internal energy in this case is the sum of kinetic energy and potential energy. Okay, sum of kinetic energy and gravitational potential energy. Therefore, we are just going to say 0.01, so we are going to say gravitational potential energy plus kinetic energy, which is 0.081 joule plus 0.24 joule, and this gives us 0.32 joule. So the answer here is 0.32 joule. Okay, that is the final answer for internal energy of the bulb. All right, explain what, that is we are on B4. Explain what happened when the particles in solid, explain what happened to the particles in solid when the temperature rises. So when the temperature rises, the particles in solid gains kinetic energy and vibrate more rapidly within the fixed position. So that is what happened within the fixed position. So that one, enough for a 1 mark. Then B, which of the three states of matter generally expand the most when heated? So the one that expand the most, states of matter, you know, that's liquid, solid, and gas, or solid, liquid, and gas. So among the three, which one expand the most? So gases. And it is because they have large spaces between the particles. So justify the answer. So due to large spaces between spaces between the particles, hence easily spread out, okay, or spread. Okay, then C question, a fixed mass of the gas occupies a volume of 200 cubic centimeter at a temperature of 27 degree and a pressure of 150 atm. If the temperature is kept constant, find the volume when the pressure reduces to 100 atm. So when the temperature is kept constant, this is Bohr's law we are dealing with, and therefore to do the calculation you are going to use this formula. So pressure 1 multiplied by volume 1 equal to pressure 2 multiplied by volume 2. If we are to collect the data here, the one that is mentioned first here is volume 1. So volume 1 is 200 centimeter cubic. That is volume 1. Okay. Then at a temperature of that, pressure of that, so pressure 1 is equals to 150 atm. Remember, temperature is kept constant, so there's no change in temperature. If the temperature is kept constant, they find the volume of the when pressure reduces to. So volume 2 we don't have, but pressure 2 we are saying pressure reduces to 100 atm. Okay, so if we replace in this formula, we're going to have pressure 1 to be 150 atm multiplied by volume 1, which is 200 centimeter or cubic centimeter, equal to pressure 2 is 100 atm, but volume 2 we do not have it, so divide 100 atm, divide 100 atm. This cancels volume 2, therefore is equals to 0 and 0 cancel, 0 and 0 cancel, atm and atm cancel. 150 multiplied by 2 is 300 cubic centimeter. So this is volume 2. All right, so volume 2 is equals to 300 cubic centimeter. Okay, B5, a person hears an explosion. A person hears an explosion of fireworks from the neighbor's house. How far does the sound wave travel in air after 3 seconds? Take speed of sound in air to be 340. So speed is equals to distance over time, which you can just write as S is equals to D over T. So we replace, what is the speed? 340 meter per second. Then equal to, the distance is the one that we are looking for. Find the distance. How far is distance? So time is 3 seconds. So we just cross multiply. So distance therefore is just the same as 340 meter per second multiplied by 3 seconds. Second and second cancels. 340 multiplied by 3. 340 multiplied by 3 is 1020 meter. Okay, so that is the answer, 1020 meter. Then B, state the factor which influences the quality of sound. So state one factor. So I can just put 2 of them. So one is pitch. Then the other one that we can put is amplitude. Okay, so these are the 2 factors that affect sound quality. So for question 6, B6, figure B6.1 drawn to scale shows a ray of light PQ. As you can see, the ray of light, this PQ, striking the mirror AB. So this is the mirror AB. The mirror AB and mirror CD, they are at right angle triangle, or at right angle to each other. QN is the normal. So this is the normal, okay, to the mirror AB. And one thing you should know about the normal is that it's perpendicular to the reflecting surface. So in this case, it forms 90 degree and also there 90 degree. What is the first question? What is the value of the angle of incidence? So the value of the angle of incidence. So the angle of incidence, if you were to look at this, this is the called incident ray. This is incident ray. So the angle of incidence is the one that is formed between the normal and the ray, and never between the boundary and the between the reflecting surface and the ray. So it is this one. This is the angle of incidence. Now, according to the law of refraction, or not going even to the law of reflection, just looking at the normal forms 90-degree angle with a boundary. So the whole of that angle is 90-degree. Now, if you already have 50, so you're just going to say 90-degree minus 50-degree. And therefore, the angle of incidence is 40-degree. So this is 40-degree. Then in figure, that is B, on figure B6.1, continue the ray PQ to show the path it takes after refraction at both mirrors. So draw to scale. So draw to scale, which means you use some measurement, but in this case I'm going to use freehand. So you're saying continue the ray PQ when it is refracted. So when it is refracted, it goes like that. Okay, let me just put it goes like this. Now, according to the law of refraction, when you have the ray of light refracted like that, then you have the normal. This angle, the angle of incidence and the angle of refraction, they are equal. So if this is 50, also this is 50. So in the case this is 40 here, also this is 40. That is something you should know. So this angle here is 40, that is how we found, which means also this angle is 40. Drawing to scale, which means you needed to measure also this angle. Then now, when it strikes CD now, mirror CD, it is going to be refracted. Okay, as well, it will be refracted. We can as well put a normal here. Okay, we can as well put the normal here. So now, how is it going to be now? How is it going to be? So after putting the normal there, what is the question asking us to do? That is for B. Continue the ray PQ to show the path it takes on both mirrors if it was refracted. So this B question, I've answered it fully just by putting this. So this is how it will come out. So it will come to the other mirror, refracted. So this is the one that comes out like that. Okay, this is the refracted ray. So when it strikes the mirror, it become more like the incident, then it is refracted. So also this is the what? Refracted ray. Okay, so now the other thing that we should take note that this is 90-degree. This angle here is 50-degree because 50 plus 40 plus 40, the whole of this one is 180. So to make it 180, this is 50. Now, if this is 50, this is 90. We can find this angle x here by just saying 90 plus 50 plus x is equals to 180. So 90 plus 50 is 140. So x is equals to 180 minus 140, which gives us 40. So this angle here is 40-degree. Now, if this angle is 40-degree, this is the normal. This is the normal for this CD. So which means this angle is 50 because the normal and the boundary, they form a 90-degree. Okay, now if this is 50, according to the law of refraction, also this one becomes 50. This is refracted angle of refraction. This is angle of incidence. Now if this is 50, which means also this one becomes 40. So you see how the angles will appear. Now, I'm sure we can answer, or we answered the other question. What is the value of the angle of refraction at CD? So the value of the angle of refraction is the angle between the normal and the refracted ray. So the angle is 50. So here the angle is 50 degree. Then the D question, what do you notice about the path PQ? So about the path PQ, which is this path, okay, and the path PQ and the final refracted ray. So which means this refracted ray, this one that we are able to see, and also this one. What have we noticed? So what have we noticed, or what we've noticed, that these are parallel to each other. So we can say ray let me just put it nicely. Ray PQ is parallel to, okay, is parallel to the final reflected ray. Okay, that is the observation that is there. They are parallel to each other. So we've answered that question fully. Then question B7, find figure B7.1 shows the circuit diagram or circuit with two resistors in parallel connected to 10-volt battery. Okay, the first question is, what is effective resistance of what? So effective resistance, they are simply asking you about the total resistance. And this is simple. If you are given two resistors that are in parallel, the formula that you use to find effective resistance or total resistance is just RT, which is resistance total, resistor 1 multiplied by resistor 2, divide resistor 1 plus resistor 2. However, this works only if you have two resistors that are in parallel. If you have more than two resistors that are in parallel, refer to this formula. RT is equals to 1 over R1 plus 1 over R2 plus 1 over R3 dash dash dash, which means and so on and so forth. You can continue in that way. Okay, this is general, applies whether you have two or more than two, but this one only two or limited to two. So you can make these n of these resistor 1 and resistor 2. It doesn't really matter. So here in that order, resistor 1 is 6 multiplied by resistor 2, which is 3, divide 6 plus 3. On top, 6 multiplied by 3 is 18, divide 6 plus 3 is 9. If you divide, you're going to have 2 ohms. Resistor measured in ohms. So 2 ohms is the answer here. The other question is, calculate the current flowing through the battery. So the current flowing through the battery is the total current in the circuit. So to calculate the current there, you're going to say resistance is equals to voltage over current. This is the formula that relates the three: resistance, voltage, and the current. So therefore current is going to be voltage divide resistor. Voltage we've been given that is 10 volts, if you remember. Then resistance, we use the total resistance for 2. So divide, we are going to have 5 amps. So therefore here 5 amps is the current flowing through the battery. Then question C, determine the charge flowing through the battery in 1 minute. So charge is equals to current times time. Time need to be in second. Okay, the current we've already found it, which is 5A multiplied by what is the time? They are saying in 1 minute. 1 minute in second is 60 seconds. So multiply by 60 seconds. 60 multiplied by 5 is 300. Charge is measured in coulomb. So 300 coulomb. So that is the answer to this question. Then of course B8, we answer B8. So figure B8.1 shows part of an electric device. Identify the electric device whose part is shown. So what part or what electric device is this? What electric device is this? Okay, so this is called the cathode ray oscilloscope, something like this. Then name the part labeled Q. So the part labeled Q is the what? Is the cathode. Okay. State one function of each of the following. State one function of each of the following. Okay. What is the function of the anode? So the function of the anode is to accelerate electrons. Okay. Accelerate electrons emitted by the cathode. Then of course part Q, if you are to look at it, is the cathode. So what is the function of the cathode? So the cathode emits electrons when heated. strongly. So emit electrons when heated strongly by the filament. You can add by the filament. So the filament is there to heat the cathode. All right. Then what about D? Why is the space between the part Q and the anode a vacuum? So this question, so I've solved quite a number of questions. So this question also, I leave it up to you. So please, as you are suggesting answers, sometimes it's very difficult to tell which answer or which question someone is answering. So when you answer, indicate question E or indicate B8. You can even indicate question number D. At least it's easy for someone to follow. Not just putting the answer without indicating the question. It's very difficult for us to follow or for others to learn. So please, as you give answers, make sure that you do that. Otherwise, I value what you do. When I say answer the questions, you do answer. That shows that you are ready to learn. All right, so we are done with question B8 up to question B9. A radioactive isotope X has the half-life of 100. So it has a half-life of 6,000 years. Define half-life. Define half-life. So what is half-life? So half-life, we can define it as the time is the time it takes for half of the unstable nuclei in a sample to decay. Okay, the time it takes for the half of unstable nuclei in a sample to decay, or for the activity of the sample to decay. There are different ways you can define half-life. You can also define it as the time required for the quantity of the substance to reduce to half of its original value. Other ways you can define it also as is the time taken for the number of nuclei of the sample of radioactive isotopes to decrease to half. So there are different ways you can define half-life, not only one way. Okay, so get to suggest also how you can define it, or get to evaluate your answer and show, see if it fits. So that is how you define half-life. Then B question, what fraction of a radioactive sample X decays after 12 years? What fraction of radioactive isotope X decays after 12 years? So after 12 years, what decays? So here we have 1 as starting point of the sample. Then half-life 6,000. Okay, it decreases to what? Half. Then after this one, so you continue adding the half-life, which means here you're going to have 12,000 years. It decreased to what? Half. Okay, so this is the sample that remains after 12 years, but we are interested in after 12,000 years, but we are interested in what decays. So if you know what remains, or for you to determine what decays, you need to know what remains. Okay, so if you have, let's say, 5 apples, then you find that someone has eaten some of the apple. For you to determine the number of those that have been eaten, you count what you are remaining with. So if you remain with 3, you are going to subtract from 5. You know that what was eaten, 2 of apple were eaten, or apples were eaten. I don't know if this is making sense in terms of this part, but what I'm trying to say is that we need the one that remained, then now we can subtract, then we find what decayed. So in this case, the original was 1, so what remained was 1 over 4. So we can say 1 minus 1 over 4, and in this case we are going to find 3 over 4. So what decayed, the fraction is 3 over 4. Okay, so that is what decayed. Or you can use ratio of what remains and that of the initial, which is 1 over 2 to the power n, where n is the number of half-lives, and n you find it by dividing the time that elapsed, dividing the half-life. The time that elapses is 12,000 years. Divide, the half-life is 6,000 years. So in this case, you are going to find a 2 as number of half-lives. If you replace in this one, I'm just trying to calculate something, please. Hope I'm not confusing someone. If you replace in the formula here, you're going to find the ratio of what remained to the original to be 1 over 2 to the power 2. 1 over 2 to the power 2 is just the same as 1 over 2 to the power 2 to the power 2, which is just the same as 1 over 4. So the ratio of the original to what remained is 1 over 4. Okay? Then now, this is just the same as what remained. Okay? In terms of fraction. So now, if we are to look at now from what decayed, so you say 1 minus 1 over 4, which gives us 3 over 4. Same applies. Different formulas, same answer. I guess you have it easy here on this particular part. Otherwise, I have some recordings where I think I explained much on this formula and also how to apply them. So please make sure that among my videos you check, you might find the use of information on this particular part. Otherwise, the answer is 3 over 4. Question C. The activity of a freshly prepared radioactive isotope X is 400 or 4,000 count per minute. How long will it take for the activity of the sample to fall to 500 count per minute? So how long is the time elapsed? And we said time elapsed, which is big T, divide half-life. This is the formula that you can use to find the time elapsed. Okay, now what do you need? You need number of half-lives and also the half-life. The half-life is given here from the question, is it 600 years? That is the half-life. So for the half-life, we are settled, we have 6,000 years. That is the half-life. What about number of half-lives? Number of half-lives, you can easily find them by just looking at it. The original sample or the original count per minute was 4,000. Half-life of this one, after 6,000 years, it reduced to what? 2,000, half of this one. Then also, this one after some years, it reduced to 1,000. Then this one up to 500. So our target is 500 from 4,000. So you count how many half-lives? 1, 2, 3. I think this is the easy way to count number of half-lives. So 1, 2, 3. Okay? So when you are given the starting and the ending, you just continue reducing it half until you reach the end. Okay? 500. So number of half-lives therefore is equals to 3. We can use the formula. Therefore, N is equals to T over half-life. T is therefore equal to number of half-lives multiplied by half-life. So we are going to have 3 multiplied by 6,000 years, which is just the same as 18,000 years. So the answer is 18,000 years. I guess you've gotten a thing here. All right. Then the last part, suggest one precaution that should be taken when handling radioactive substance X or radioactive isotope X in the laboratory. Okay, so this one being the last question, I leave it up to you as well to see those that have gone up to the end. It's very important that always you finish the information that is presented. Very important. All right. So we've come to the end of the presentation. So please, if you are interested to join us for physical lessons, we are found in Kabwata, okay, near Kabwata Primary School. And the good part is that we also offer free lessons, free revision, that is over the weekend. You can come through over the weekend, 14 hours. We'll help you with any topic that you have challenges with. So would you be interested to join us or you stay near? You can just contact the number 0976 402563. Those outside Lusaka, also you are catered for. We offer online lessons. You can still WhatsApp the number and of course we can start together. Online lessons are interactive and also even more powerful than physical lessons because there everything is recorded afterward you are given the information. So please, if you are interested to join us, make sure that you get in touch. Otherwise, we can end here and see you in the next one.